Bearings are something that I feel a lot of students struggle with. Now, there's 3 key rules to bearings, and I'll explain to you why. All bearings are measured from north. That is because originally, before we had things that could measure where we were, so GPS and accurate clocks that kept time, the only thing that sailors could rely on would be the North Star. So they always use their starting point as the North Star every time. And they would describe how far they travelled according to this. Now, the thing is, with a bearing, you always have to travel clockwise, because if you described how far you travelled as a degree or as an angle, but you didn't state which way from north you were turning, you could end up in a completely different area or in a completely different direction to where you were meant to be. So for instance, if we'd gone anti-clockwise, so that means that we're going in the opposite direction to which the clock what's the word I'm looking for?
Clock goes round the clock face. The hand moves round the clock.
The clock hand, there we go. The clock hand was turning, so a clock would usually go clockwise, hence why it's called clockwise, which would be this way. If you're going anti-clockwise, that means you'd be going into the opposite direction to a clock. So anti-clockwise, look, if we turned exactly the same amount, but in anti-clockwise, we'd be facing this way. Well, that's a very big difference to where we actually want to be. So the important thing to remember with bearings is that we need to describe it in a clockwise direction. Then we always need to write 3 digits. So for instance, if I travelled, say 98 degrees from north to here, then we would describe it as 008, so that we never confuse, for instance, something like 36, we wouldn't confuse this with 360. So we always put a 0 in front to show that we're working with an angle that's less than 3 digits, so less than 100. So the key ideas are always measure from north, you always have to go clockwise, and you always need 3 digits so that they can't be confused. So say for instance I've got my ship, okay, and I'm going to put him here, so that's where he's going to sit, and he's going to travel on a bearing of 173 degrees. Now that might be all the information they give you to start off with. So draw a point, do a sketch. Okay, bearings are a visual thing, so draw a sketch. Don't just rely on the paragraph that they give you, draw it. And if you need more paper, ask for more paper, and just hand the paper in with your exam. Make the exam your own. Use it how you need it to be used. So I'm going to draw a north line. Remember, this is just a sketch, it doesn't have to be beautiful. And I know that 173 degrees is going to be nearly 180, but not quite. So it's kind of going to be here somewhere. So I'm going to draw an arrow to show the examiner that I know that it's clockwise from north. So look, I drew a north line. And then I'm going to put a point where I think it's roughly going to stop and draw another north line in. And that's my sketch. Now, what the examiner might do is ask you to find the back bearing. Now, a back bearing is what you need to travel from where you started from to your new point would be your bearing. So this is our bearing. Our back bearing would be how far you'd have to travel from your new place that you reached back to where you started from. So it's basically your reverse bearing. So there's two ways to look at this. I would suggest that you recap before you spend a lot of time on bearings, that you recap your parallel line rules. Now, because all of the bearings that you use are based on north, you suddenly have two parallel lines. So all of your parallel line rules, for instance, your co-interior, your alternate, your supplementary, they're all going to count here. So essentially, when you go from one point to another point, you have a transversal line, and that means that this angle here is the same as this angle here because they're alternate. And I know that this angle here and this angle here add up to 180 degrees, and that's called the co-interior rule. So I know that if this plus this has to equal 180 degrees, then I know that this 173 plus whatever's in here has to also equal 180. So 180 minus 173 equals 7 degrees. So I know that this is worth 7 degrees. So now what I can do is say, well, if I travelled the entire way round to my north line again, that would have been 360 degrees. But our bearing hasn't travelled the full way round. It's 7 less than 360. So I'm going to do 360 minus 7, and that's going to give me 353 degrees. So I know that this back bearing, so the one that I need to return to where I started, is worth 353 degrees. The other way to look at it is this. The first thing to do is to make these north lines easier to look at by extending them down. And then suddenly it does look a lot more like a pair of parallel lines that you've been used to seeing when working with your parallel line rules. Now, I know that because of the alternate rule, which some of you might think of as Z angle, but you mustn't use that terminology, that this line here, this will be the same as this here. So I know that that's 173 degrees. Now, if I'm facing north and I have to travel all the way around to face up here, I have to travel 180 degrees and then my extra 173 to face this way. So what you can do is either look at it in terms of 360 using a co-interior rule. So here, to find the 7 degrees, we use the co-interior rule. Okay. Here, we're using the alternate rule, and we're just adding 180 degrees onto our original bearing, which would give us 353. Now, the thing is, this looks really easy, but you've got to be aware of the fact that if you end up with a bearing that's greater than 180, it's going to work slightly different. And that's why I always encourage my students to use this method. So for example, say for instance here, we have our ship here at this point, and we're going to call that A, and it has a bearing of 223 degrees. and it's going to travel to a point. It doesn't matter where our point is at this point. It's just that we know it has to face this direction to get to the point it wants to. I'm going to call that B. And then I'm going to draw my north line on. Now, this, the easiest thing to work out would be to know that this angle here is worth 360. So just to give myself an idea of what the bearing is, okay, I need to calculate the back bearing as well. So at the moment my bearing is 223 degrees, and they're asking me for my back bearing, so my return bearing. So my first bearing allowed me to face this way to get to B. Now I need to know how far I need to travel to face towards A, and that's my back bearing. So I'm trying to find this. I'm going to call that BB. So the first thing I would do is write in everything that I know. I'm just going to draw some extra lines on just to help myself. And I'm going to work out what this angle is in here. So I'm going to do 360 minus 223 because it's not quite an entire circle, which is 137 degrees. So I know that if this is 137 and this have to add up to 180, I know that this must be 180 minus 137, which equals 43 degrees. Now, 43 degrees isn't my final answer because I have to put it into 3 digits. So my final digit would be 043 degrees. Job done.